11. Oh, I'm sorry, I put real numbers. That is actually not the topic. The topic is rational numbers. There is such a thing as a real number, and there is such a thing as an imaginary number. But that's not what we're doing. So rational numbers, sorry about that, is our topic here. It's actually the topic for all of chapter 11. So first of all, what is a rational number? A rational number, and so I'll show you some examples. And we did this last year. I don't expect you to remember the specific vocabulary, but hopefully as I show it to you, it might come back a little bit. A rational number can be expressed, hold on, I just want to turn on the light because I can see it trying to adjust the lighting and the color keeps changing. Okay, a rational number can be expressed as the quotient, remember that means answer to division, as the quotient of two integers. For example, A over B. Think of a fraction, right? In a fraction, now an integer means a whole number. So the quotient of two integers means we're doing division on two whole numbers. So if you think about a fraction, for example, instead of A over B, if we said 3/4. Now I can see in this form that this is a rational number because it fits this pattern, dividing two whole numbers. Can anybody think of another way that we could show the amount 3/4? Jim? What's that? Oh, okay, so as another fraction, Jim gave a non-simplified fraction. So that's another way. That still follows this pattern though. Can anybody think of another way to say 3/4 where it doesn't look like a fraction? Diego?
3 to 4.
Okay, a ratio. Or, what about a decimal? So 3 to 4, as Diego said, that's another way to show it. He's talking about doing it as a ratio. And we're not actually going to be working with ratios here, even though that word is in rational. The idea here is that any number, for example, a decimal, could be a rational number if it could be turned into a fraction where the fraction has whole numbers as both numerator and denominator. So let me just show you a couple other examples. What if I had -1 and 4/5? That doesn't fit this pattern of A over B, of what a rational number is. Can I change the form of this to make it look more like A over B? So part of what you're going to be doing is taking numbers and showing them in their rational number form. Izzy? Okay, so as an improper fraction, you just had it backwards, 9 over 5. Remember, first of all, we don't worry about the negative. As I turn this into an improper fraction, I don't look at the negative. If it's a negative mixed number, it'll be a negative improper fraction. So I just do 5 times 1, not times -1. 5 times 1 is 5, plus 4 is 9. There it is in its rational number form, -9 over 5, or 9 over -5, or negative out front, 9 over 5. But either way, we've changed it to this format. Okay, how about 48%? How could I write that in rational number form? Thinking we want it to look like a fraction. Brian?
48.
Okay, good. 48, any percent, we can start by putting it over 100. You're going to be asked to simplify whenever possible. Now, we don't want to simplify this 9/5, we'd get back to what we started with. But here, these both divide by 4. So if you are asked to do simplest form, we just simplify the fraction, regular fraction simplification. Okay, last example, what if I had 0.6? How could I write that in its rational number form? Vincent?
6/10.
Yeah, just read the decimal. 6 what? 6/10 because of this place. 6/10, 6/10. And then, of course, we could simplify that to 3/5. So first of all, I believe in your book for this, where you're going to be turning them all into rational numbers, the directions will say write as a quotient of integers. Might be how the directions are on that. Let me double check. Yes, it does. As a quotient of two integers or as a quotient of integers. So if you see that, it's just this, practicing turning them into their other formats. Okay, now, a couple other things we're going to do here. We're going to compare rational numbers. So, figuring out greater than or less than each other, so comparing them to each other. So if I have, for example, 8/3 and 17/7. There's a couple different ways you could compare these. If you were going to need to put a greater than or less than symbol in between, right, we need to figure out which one's bigger. Anybody have an idea for one way to compare these? It's hard just by looking. Diego?
Doing the same denominator.
Okay, one method is to turn them into the same denominator. Let's try that. If I have 3 and 7, common denominator would be 21, right? So times 7 on the 3, 8 times 7, 56. These are both improper fractions, but that doesn't matter. We can leave them that way. We just want to find out which one's bigger. 7 times 3 to get to 21 on this equivalent fraction. So then 17 times 3, and we get 51. When they have the same denominator, you just look for which one has the bigger numerator. So here, we can see 56 is bigger than 51. So that is one way to compare, and that is a good way. It will always work. Anybody have an idea for another method? You could turn them, oh, Vincent? Yeah, you could try turning them into a decimal. Now, that way is good for this type of problem. I'm going to show you another problem in a minute where you have to keep it in fraction form. But for this, you could say 8 divided by 3, and I get 2.6 repeated. And then 17 divided by 7, and I get 2.42, and then it keeps going. But I don't need any more than that. I can see which one's bigger. In your answer, I want it to be with the original numbers. If you use equivalent fractions, if you use decimals, either one's okay. Let me show you one other method. This is going to be probably new for most of you, but one other way you could compare. So if the fractions were hard to compare, now let's see here. Let's say we do 4/7 compared to 3/8. Here is a little trick we can do. We're going to kind of cross multiply, but normally remember cross multiplying would be if there was an equal sign and a missing number, a variable. Here's what we're going to do. We're going to cross multiply and we're going to keep them in the order that they're in. So I start up here, 4 times 8. I'm always going to start with this cross. 32, 7 times 3, 21. If it is true, now we're always going to start with this sign. If we start with a greater than every time, and we start with this cross every time, if it is true that 32 is greater than 21, which of course it is, then it is true that this is our symbol. If we did this, let's say we had the 3/8 first, and then the 4/7. We would start with the greater than symbol, but we do our cross, 21 is greater than 32. Well, that's not true. So if it's not true, then what it means is we open to the other one. It's just a little shortcut trick. You can use it if you want. You don't have to. In your book, they show it with A and, what's their B? B, and they show it with letters first. It's a little shortcut trick. If you start with the greater than, if it's true, then it stays greater than. If you start with the greater than and it comes out not true, then the sign should be less than. Okay, so that's a third method you could use if you want. Now, the final thing I need to show you is find a number halfway. Here's where we're going to need to keep it as fractions. Halfway between, and then you'll be given two fractions, and we're going to try to find the number that is halfway in between 3/4 and 5/6. So first of all, here's what you cannot do. I'm going to put it over here with a line through it. Here's one thing you cannot do. Oh, 3 and 5, well, between that is 4, and 4 and 6, between that is 5. No. That doesn't work. You can't go, oh, 4 is between 3 and 5, and 5 is between 4 and 6. The numbers might be in between, but that doesn't mean as an amount that it is the halfway point in between. So here's what you're going to do. For these problems, you'll only have a couple of these. The first thing you're going to do is find an LCD. For 4 and 6, of course, we could use 12. So the first thing you're going to do to find the middle, the halfway point, is to turn them into having a common denominator. 4 times 3, so 3 times 3 makes 9. 6 times 2, so 10 twelfths. Okay, hopefully everybody's good on that part, turning equivalent fractions into their common denominators. Now, here's the tricky thing. We need to find the halfway point in between here. We're still in twelfths. So we look at the numerator. Now you have two methods. You could just do mental math and say what's halfway between 9 and 10. It might get tricky. This one hopefully won't be too hard, but you might have some that are harder. Here's how you can find the numerator, is find the average of the two numerators. If you remember doing average, what that means is we add the two things up, and I'm going to use the numerators 9 and 10, and I divide by how many things I added. So if I add them up, I get 19, 10 plus 9, and I divide them by 2, because I added two numbers, so I divide by 2. And this will give you your halfway point. I'm sure many of you could have thought in your head for this one, oh, it's 9.5. But if you can't do that, or you're not sure, or when the numbers get harder, you take the average of these two. Now, here's the problem here. I want this answer to be a rational number. That's what our topic is. Is this an integer in the numerator, a whole number? No, right? It's a decimal. And as I've always said, that's ugly. We don't want a decimal in our fraction. So this is not in rational number format because of that decimal. So we need to finish this problem by changing this 9.5 over 12 into a rational number. Here's what we're going to do. It's always, if you have a decimal, because we're always doing just 2 in between two numbers, it's always going to be a half. So the step, if you get this, is always going to be the same. Multiply them both by 2. On the bottom, that gives us 24. 9.5 times 2. You can use your calculator for that. 19/24. This is the rational number that is halfway in between our original fractions. Sometimes, if you get a whole number for this, if this was between 9 and 11, well then halfway in the middle would be 10, and 10/12 is your answer. But if you get a decimal, you're always going to do the same thing to get rid of it. You're going to multiply by 2. That gets rid of the half. So you multiply both numerator and denominator by 2, and there's your answer for your fraction that's in between. Okay? That's it.